We're given h of x is f of 4x times ln of kx plus e to the f of x. F of 0 is 0 and f prime of 0 is 2. Let's find the tangent line at x equals 0. So let's first take the derivative. For the derivative, we need to use a product rule. So the derivative of f of 4x is 4 times f prime of 4x. And then we're going to multiply that by the natural log. Plus, now take the derivative of natural log. That's going to be 1 over the entire inside, which is kx plus e, times the derivative of kx plus e, which is k. And multiply that by f of 4x. Now we need to take the derivative of e to the f of x. For e to the f of x, we leave that the same, so we have e to the f of x. And then by chain rule, take the derivative of the exponent, which is f prime of x. Now for the tangent line, you want a point and a slope. So let's first find the point at x equals 0. Plug in x equals 0 just plug in x equals 0. And then you have f of 0 times ln of e plus e to the f of 0. F of 0 is given to us as 0. So this is 0. ln of e is 1. E to the 0 is just 1 as well. So 0 times 1 is 0, plus 1 is 1. Now plug in x equals 0 in for the derivative. So we're left with 4 times f prime of 0 times ln of e plus k over e, because here x is 0, so kx disappears, times f of 0 plus f prime of 0 times e to the f of 0. F prime of 0 is given to us as 2, and ln of e is 1, and then f of 0 is 0, so this whole thing is 0. F prime of 0 is 2, and then e to the f of 0 is just 1. So what we have is 4 times 2 times 1, and then plus 2. Well, 4 times 2 times 1 is 8, plus 2 is 10. So the derivative of x equals 0 is 10. Now we're going to bring this together. We need the point and the slope. The point is 0, 1. The slope is 10. So for this, because we have x equals 0, y equals 1, this is also the y-intercept. So we could just use the form y equals mx plus b to find the tangent line, where b is the y-intercept. So the slope is 10, so substitute m equals 10, and the y-intercept is 1, so b is 1. And so our tangent line is y equals 10x plus 1.